Hello, Namaste. Good evening, everyone. Hmm? So today we will have second session on redox reaction. In the previous class, we were discussing about the various method in which we can define oxidation reaction as well as reduction reaction. Correct. One such way was um, removal of oxygen and addition of oxygen. Oxidation means addition of oxygen, and reduction means removal of oxygen. And the other one was using hydrogen. Removal of hydrogen means oxidation, and addition of hydrogen means reduction. The third one was electronegative and electropositive. Oxygen was substituted with electronegative to get a broader picture of it. Isn't it? So whenever electronegative atom is added, which is oxygen-like, then it is oxidation. And whenever electropositive like element is added, which is like hydrogen, then it will be reduction. And we looked into various examples of that kind. And then finally we ended up with oxidation number. Correct? Yes. So we understood what is oxidation reduction reaction. And today's class we will be learning about oxidation number. Okay. What is this oxidation number method? This is one method by which we can define our oxidation reduction reaction. Okay. So how to find out oxidation number? There are a few rules. The first one is sum rule method. Okay. This is the universal rule which is applicable for all molecule as well as charge. Sum of oxidation numbers of element. By the way, let me just recollect what exactly we defined our oxidation number as. It is the notional charge on any atom when the bond is broken. Correct. So, with that understanding, let us continue ahead. Sum of oxidation number of elements in a molecule is 0 and in an ion is equal to the charge of the ion. So what does that mean? If I take, let's say, H2O, then the oxidation number of hydrogen will be in a way that, and oxidation number of hydrogen as well as oxidation number of oxygen will be in a way that when you add all of them, algebraic sum if you take, it will become 0. For example, for now I'll take hydrogen oxidation number to be equal to 1 and oxygen to be equal to -2. So let's just do algebraic addition. Here 2 hydrogen atoms are there. So 2 into 1 minus oxygen, 1 is there and charge is -2. So it will be -2, which is equal to 2 minus 2, which is 0. So algebraic sum will be 0. That's what the sum rule method says. And for a charge, if there is any charge on the ion, then the algebraic sum will be equal to charge on that ion. For example, SO4, 2 minus. In this case, sulfur will have some oxidation number, oxygen will have some oxidation number in a way that when you add all together, it will come out to be -2. I'll just write down. If the compound is something like this, S double bond O minus, O minus. Would anyone like to tell what is oxidation number of sulfur in this? Yes? Yeah. Try to break all the bonds and tell me what could be the oxidation number of sulfur, which we did last class. Yeah. Would anyone like to reply for this? Yes. If I break this bond, here +1 will come, here -1 will come. When I break this bond, both charge goes to oxygen because oxygen is more electronegative. So -2 will go here and +2 will come here. When I break this bond, here +1 will come, here -1 will come. So all together on sulfur, oxidation number will be equal to 1 plus 2 plus 1, which is 4. Clear? So yes, you have to be careful which one will get negative, which one will get positive. Okay, when this bond breaks, oxygen is obviously more electronegative, so it will take away electron from all sides. Sulfur will be left with positive charge, plus one, and then plus two, where there is two bonds. Meanwhile, on oxygen, it will be minus one, and there is one minus charge also. So it will be minus two. More about this I'll discuss in next slide. But as of now, you consider that oxygen will have only minus two, minus two, minus two. Okay. Yeah. So yes, since this is having only three oxygen, there will be another double bond. Okay. So from there, when you break, another two charge will come. So plus two. Okay. Yeah. So it will be 4 plus 2, which is 6. Because SO4 is there. Na? So 4 oxygen should be there. Not 3, 4. So then oxidation number of sulfur will be plus 2, which is 6. Clear? So then oxygen will always have minus 2. So it will be plus 6. Algebraic sum will be plus 4 into minus 2, which is equal to 6 minus 8 equal to minus 2. Clear? So that should be equal to the charge on the ion. Either if it is a neutral molecule, then it should be equal to 0. If it is a charged molecule or charged ion, then the algebraic sum should be equal to charge on that ion. That is the whole point. Okay? Yes. But now there comes a difficulty in finding out oxidation number. Correct? From somewhere we need to start. If bond is not given to us. In case of SO4, I told it looks something like this. So you were able to find out the oxidation number. But in general, it is little difficult to find out oxidation number. And we have certain general rules. Okay. Oxidation number of element in free state is 0. Okay. So for example, Cl2 free state. Free state means diatomic. Yeah, only one kind of element it will be. Okay, only one atom. So H2, where only one atom exists, then we call it as free state. So in that case, oxidation number will be 0. That we can prove also. Let's say oxidation number is X. So 2 hydrogen are there. We already know that algebraic sum 2x plus nothing is there. That should be equal to 0 because it is a neutral molecule. Correct? Hence, the oxidation number itself is 0. Got it? So in free state, oxidation number of element is 0. Second one, oxidation number of hydrogen is always plus 1. Okay? Oxidation number of hydrogen is always plus 1 except in case of metal hydrides. Okay? Why in case of metal hydrides it is minus 1? Because finally one thing you should be knowing that oxidation number has something to do with electronegativity. So when you compare hydrogen with non-metals, hydrogen will have plus charge. For example, if you take H and Cl, hydrogen will have notional charge of plus and chlorine will have notional charge of minus. Correct? But when you take, let's say, sodium and hydrogen, then sodium will have plus because sodium is now electropositive, hydrogen is now electronegative. So that's why whenever hydride comes in question, if they ask lithium hydride, you should know that hydrogen will have minus 1 oxidation number. Hydride means minus 1. Okay. Hydrogen chloride, it is plus 1. Hydrogen has oxidation number of plus 1. Clear? Keep this in mind. Hydride minus 1. Why it is minus 1? Because it is competing with electropositive element. That's why it will get a negative charge, minus 1, notional charge. Third one, oxidation number of oxygen is minus 2. Same thing. Okay. So notional charge on oxygen will be minus 2 in general. But in case when it is reacting with highly electronegative atom, now for example, fluorine is very electronegative. So in that case, fluorine will get negative notional charge, and because of which oxygen will get positive notional charge. So in case of OF2, it will be plus 2. Okay. And in case of peroxide, it will be minus 1. Okay. Best example for peroxide would be H2O2, hydrogen peroxide. So in case of hydrogen peroxide, hydrogen is there. So plus 1 charge on hydrogen, and we have sum rule method. What is that? Sum, algebraic sum of all the oxidation number should be equal to 0 if it is a neutral molecule. So I'll do algebraic sum. Let's take oxidation number of oxygen as X. It will be 2 into 1 plus 2 into X, correct? Because 2 atoms of oxygen is there, should be equal to 0. So if I do calculation, I'll get X equal to minus 1. Got it? So that's why notional charge on oxygen will be minus 1 in case of peroxide. Clear? Whenever oxide, something like that comes, it will be minus 2. But peroxide, superoxide, it will not be minus 2. Just oxide, minus 2. Peroxide, minus 1. OF2 is a special case where it is combining with halogen or electronegative element. That time you should not apply oxidation number for oxygen. Okay, rather you should apply oxidation number for halogen, which I will discuss in the next slide. Okay. Oxidation number of metals is always positive. Why? Because metals are those substances which tend to lose electron. For 1A group element, it is plus 1, and for 2A group element, it is plus 2. For example, if I take lithium, oxidation number will be plus 1 because it comes in first group, right? So it will be plus 1. Na plus 1. Then potassium plus 1. All in that line will be plus 1. Clear? And then 2A, which is beryllium, yeah, magnesium, calcium, all of them will be having plus 2. Clear? Yes. So 1A element will have oxidation number of plus 1. So now if there is a competition between 1A element and hydrogen, one example is lithium hydride. So then hydrogen will get minus 1 and 1A element will get plus 1. Got it? Because 1A element is electropositive. They will get notional charge of plus 1 and hydrogen will get notional charge of minus 1. Similarly, competition between magnesium and hydrogen, magnesium hydride maybe. Yeah. So then again hydrogen will get minus 1, magnesium will get plus 1. Got it? So yeah, electropositive element usually will get positive notional charge. That's why you can see there is no exception. Clear? Oxidation number of halogens is minus 1. Okay. In case of metal halides. Yes, that means there is some other case also. So for halogen, for example, if I take HF, fluorine is halogen, so it will have oxidation number of minus 1. HCl, chlorine is halogen, so it will have oxidation number, fluorine will have oxidation number of minus 1. Then HI, again here also oxidation number is minus 1. Clear? So whenever not so electronegative element is attached to halogen, which is highly electronegative, then electronegative element will get minus 1 charge. But then there are few elements like ClF3, IF5. So here you can see that chlorine is electronegative. Obviously both are halogen. Chlorine is also halogen. Fluorine is also halogen. Isn't it? Group 17. So in that case, what to do? In that case, fluorine, which is more electronegative, is going to have minus 1 charge, and chlorine will have, depends on how many halogens are attached. So chlorine will have some X, which we can calculate using sum rule method. Clear? So whichever is more electronegative, that will get minus 1. But one thing is for sure, that oxidation number of fluorine in its compound with other element is always minus 1, because fluorine is IH, right? It It is having most electronegative. There is no competition between fluorine and any other. Okay. Whereas in case of chlorine, if it is competing with fluorine, then fluorine oxidation number would be different. Depends on how many fluorine are attaching. For example, if 3 are attaching, then by using sum rule method, what I can say, let's say our notional charge or oxidation number is X plus 3 into charge is -1 should be equal to 0. So X will be equal to 3. Got it? It is no longer -1, it is +3. Whereas in case of IF5, oxidation number of iodine will be +5. Just check it. Again using algebraic sum rule method. Oxidation number of nitrogen in metal nitride is -3. Yeah. For example, you may take NaN3. Yes, in all these cases, sorry, Na3N. In all these cases, what happens? Sodium will have +1 and nitrogen will have -3. Wherever nitride comes, sodium nitride, lithium nitride, wherever nitride comes, nitrogen will have oxidation number of -3. Last one, in metal carbonyl. What is this metal carbonyl? Carbon monoxide getting attached to a metal. And amalgams. Amalgams also, a metal remains as it is and it forms a partial bond with some other substitute metal. Yeah. So in such cases, the metal's oxidation number will be 0. Yeah. Yes. So now let us try to apply all the rules that we have learned into the questions. In question, most expected, and a few times it comes in competitive exam as well, that they will ask you to find out oxidation number of few unknown element. For example, I already discussed for potassium like element what is oxidation number. For oxygen like element what is for oxygen what is oxidation number, that also I have discussed. But chromium I have not discussed. But you can use some rule to find out oxidation number of chromium. Would anyone like to answer this? What will be the oxidation number of chromium? Maybe you can use, you can take oxidation number of chromium as X and then use some rule to find out the value of X. I'll give you 30 seconds. Quickly try to do it and tell me the answer. By the way, this is potassium dichromate. Potassium dichromate. Yes. So potassium is group 1A. So it will have oxidation number of +1. Oxygen is -2. Yes. Until and unless we have peroxide, superoxide, something like that, we will use -2 itself. Okay. So then some rule says algebraic sum, add everything, yeah, along with their charge. That should be equal to 0 if it is a neutral molecule. So here 2 into charge is +1. So 2 atoms of potassium are there. So 2 into 1 plus 2 into X plus 7 atoms of oxygen is there. So 7 into notional charge oxidation number is -2, which is equal to 0. Clear? So further on solving, we'll get 2 plus 2x minus 14 equal to 0, or x equal to 12 by 2, which is equal to 6. Clear? So let us look at this solution. So if oxidation number of chromium is x, then we can apply algebraic sum and we'll get x value to be equal to 6. Yeah, potassium is group 1A. Group 1A, that means it can develop a notional charge of +1. Okay. Yeah. So, since two atoms of potassium are there, hence it will become 2 into plus 1. Okay? It will not be plus 2. Calcium will be plus 2. Because calcium is in group 2A. That's why it will be plus 2. Yes, yes, good relation. Next one is potassium permanganate, KMnO4. Even here, oxygen will exhibit its -2 oxidation state only. So, using this understanding, try to find out oxidation number of manganese quickly. Quite direct. Yeah, very good. This we has answered for previous question as +6. Good. What about KMnO4? Should not take more than 30 seconds. Quickly, you should be able to. Yes. So if we take the oxidation number of manganese as X, then the algebraic sum should be equal to 0, which is 1 into plus 1 plus 1 into X plus 4 into minus 2. So if I solve this, I'll get X to be equal to 7. Yeah. Fine. So hope you understood this. Going ahead, NaO2. So here comes the example of superoxide. So superoxide means what? I don't know what will be the oxidation number of oxygen. As of now, I don't know. But superoxide will always have some oxidation number of oxygen. So let us find out oxidation number of oxygen in superoxide. How to do that? We know for sodium for sure it should be +1 only, always, because you should remember this. Group 1A and group 2A will always have oxidation number of +1 and +2 respectively. Okay, they cannot be different. Okay, yes. So, using that understanding, try to find out oxidation number of oxygen in superoxide. Try to find out that. Yes. See, let oxidation number of oxygen should be X, because we don't know it is in superoxide form, right? Hence, by using algebraic sum, we can say +1 plus 2x equal to 0. On solving, we get x to be equal to -1 by 2. Clear? So oxidation number of oxygen you can add to that point, to the previous one in the oxidation number. All the rules that are there, you can also edit that. Oxidation number of oxygen in superoxide will be equal to -1. Yeah. Now we got to know about that. Yeah. Okay. Next, try out Fe3O4. Try out this. Yes. Ferrous oxide. Very good. Students are replying. Yeah. Find out oxidation number of Fe3O4. Yes. Here there is one more interesting conclusion that you will come about. Yeah. Once you find out the answer, you will get to know something new. Yeah. Yes. Here, which is the unknown? Iron is unknown. Oxygen, oxide, so it will be -2 only. So if you put, what is the oxidation number of iron that you are going to get? Yes. If I solve it, I'll get x to be equal to 8 by 3. Isn't it? Yeah, so now just imagine, can the charge on any atom be in fraction? Yes. We know that oxidation number means it is a notional charge. So can that charge be fraction? No, right? Either one electron can go or one electron can come. How this fractional charge can come? It's not possible. But in few cases, it is possible. Why? Here you can see that the oxide Fe3O4 is mixture of these two, which is having oxidation number of +2 as well as +3. So combined together, their oxidation number will be somewhere in between +2 and +3. That's why we will get oxidation number as a fraction. Okay. So conclusion is that oxidation number of an element can be integer, which is obvious, fraction, or it can be zero also. Yeah, one such example is the diatomic molecules, correct? In their free state, with zero. Try out next. HNO3. HNO3. This is not nitrite. This is nitric acid. To find out the oxidation number of nitrogen in this. Yeah. Yes, students can reply. Yes. Only when you all reply, uh, that is the indication that you are understanding. Okay. Yes. What about nitric acid? What will be the oxidation number of nitrogen? Yes. So here also you can consider oxidation number of oxygen as -2, hydrogen as +1. Using that, what will be the oxidation number of nitrogen? Yes. So by doing algebraic sum, I'll get x equal to 5. Clear? Next, try out this CaOCl2. Find out oxidation number of chlorine in this. CaOCl2. Yeah, calcium. As I had previously said, calcium has oxidation number of +2. Oxygen has oxidation number of -2. So we got it directly. So let's say chlorine oxidation number is X. When I add all of them, it will be 2 minus 2 plus 2x equal to 0, or 2x equal to 0, x equal to 0. Yes. So what is the conclusion from this? Conclusion is that chlorine, how it can have 0 oxidation number? That means 0 charge on chlorine. It's not possible, right? But it is possible to have final charge 0 because of +1 in one case and -1 in another case. And how +1 comes on this chlorine? It comes because it is combining with oxygen, which is electronegative. Clear? Since oxygen is electronegative, that will have -1 and this chlorine will hence get +1 when you break this bond. Okay. Whereas here, calcium and chlorine, definitely chlorine will get -1 and calcium will get +2. And that is how chlorine resultant, the combination of both the chlorine together will have oxidation number of 0. Okay. Yeah, PO4 3 minus. Try to do it quickly and tell me the answer. What would be the answer for this? Yes. Again, the same logic that here the oxidation number will be -2, phosphorus will be X. So if I do algebraic addition, it will be X plus 4 into -2, but instead of 0, now it will be -3. But since it will be -3, the X value will become equal to 5. Yes. Going ahead, Ki3. Try out Ki3. I want this to be done by all of you. Tell me the answer quickly for Ki3. What will be the answer? Yes, what will be the oxidation number of iodine in case of Ai3? Yeah. Yes. Again, the same rule. Remember that group 1A and group 2A will always have oxidation number of +1 or +2. Yeah. But halogen other than fluorine can have different oxidation state also. So using that logic, I'll take oxidation number of iodine to be X. Okay. Then when I do algebraic addition, it will be 1 into 1 plus 3 into X equal to 0. X will be equal to -1 by 3. Clear? Yes. So why were we discussing all of this? Because as from the beginning we were going that oxidation and reduction can be defined using oxygen or hydrogen, electronegative, electropositive, and now we have got another way to define oxidation and reduction. Oxidation involves increase in oxidation number and reduction involves decrease in oxidation number. So in any reaction, if you see that some atom, the oxidation number of that atom is decreasing, then it is undergoing reduction. If the oxidation number of that atom is increasing, then it is undergoing oxidation. For example, if you take this Cu2O plus Cu2S gives Cu plus SO2. Quickly tell me, yeah, quickly you should reply, what is oxidation number of copper in this? Quickly. Yes, whoever is there, quickly tell me, what is the oxidation number of copper? In case of Cu2O and in case of Cu2S. Okay, I'll give you a hint. Sulfur comes below oxygen. So sulfur will also have oxidation number of -2 as oxygen. First one is cupric oxide, second one is cupric sulfide. So quickly tell me, what is the oxidation number of copper? Sorry, it's cuprous oxide and cuprous sulfide. Quick. Now that you have solved around 5 to 6 questions, this should be very quick for you. There is nothing in this. Yes, how much is it? Yes, in both the cases, it will be +1. +1 and +1. So this +1 is getting reduced to copper solid, which is having oxidation number of 0. And sulfur, if you observe here, it is sulfur dioxide. So -2 into 2. Yes. So here oxidation number is -2. Let's say this is X. Then you will find that X will be equal to 4. Okay. So sulfur oxidation number is increasing. Copper oxidation number is decreasing. So copper is undergoing reduction and sulfur is undergoing oxidation. It is oxidized from -2 to +4 and copper is reduced from +1 to 0. Clear? Yes. So in oxidation number, we didn't had oxidation number specifically for transition elements. Why so? Because these transition elements have variable oxidation state. Sometimes they will have +2, +3, +1, +4. Yeah, dependent upon which atom it is undergoing, what type of reaction. Okay. Yes. So that is why always for transition metals, we need to find out oxidation number using surrounding atoms. That could be alkali metals, alkaline earth metals, yeah, group 1A, group 2A, or halogen. Yes, all of them. Yeah. So nitrogen, phosphorus, arsenic, bismuth, all of them also have variable oxidation state. Yeah, one will be predominant. This more about this you will be learning in P block. P block. One will be predominant, and other will be not so much reactive. Yes. So to represent this variable oxidation state, we have something called a Stock notation. The Stock notation was introduced by a scientist named Stock. Yeah, and when there are variable oxidation state, for example, ferric chloride and ferrous sulfate. In this case, iron has oxidation number of 2, and in ferric chloride, oxidation number of iron is 3. So that's why we can use Stock notation to represent the oxidation number in different cases. So iron will have 3. So in Roman we'll write 3, and ferrous sulfate will have oxidation number of iron as 2. So we'll write Roman number 2. Okay. Yes. So Cu2O is cuprous oxide because here oxidation number of copper is +1, or copper Roman number 1 oxide. This is ferric oxide where oxidation number of iron is 3. Whenever ferric is there, it is +3. Whenever ferrous is there, it is +2. Whenever cupric is there, I think this all thing you might have learned previously. Cupric is there, it is +2. Cuprous is there, +1. Okay. Mercuric chloride +2. So that's why Roman number 2. Stannous chloride. So Roman number. Yeah, here are few examples for which you need to find out oxidation number of transition metals. For example, here gold, or here titanium, yes, iron. For all of this, you have to find out oxidation number and write down in Roman numeral. That is Stock notation. Yes. So try finding it out. Yes. The first one, if you see, it will be +1 -1 into 4. If you perform algebraic addition or sum rule, it will come out to be +3. So gold has oxidation number of +3. And Stock notation in that, we will write Roman number 3. Yes. So similarly, we can do ferrous oxide, ferric oxide, titanium oxide. Yeah. CuI plus iodide, cupric oxide, manganese oxide, manganese dioxide. Yes. So if you look at it, here 3 Roman will come, 1 will come, 2 will come, because oxidation number is respectively 3, 1, 2, 3. Yes, 1, 2, 2, and 4. Yeah. Yeah. So here is exercise for you. Maybe you can take it down and try to do it later. Suggest a list of the substances where carbon can exhibit oxidation state from -4 to +4. Yes. So I'll skip the solution so that you can do it right on your own. The hint is that carbon will have less oxidation state when it is bonded with hydrogen, and it will have more oxidation state when it is bonded with oxygen. Okay, because oxygen is an electronegative element, or addition of oxygen will increase the oxidation. Yeah, it will get oxidized, or oxidation number will increase. Okay, with this logic, try to find out many different compounds of carbon where carbon will have oxidation number -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, this is homework for you. Yes. With this understanding, now we'll go to the types of redox reaction as well as what exactly is meant by oxidizing agent and reducing agent. Yes, previously we already know certain thing about oxidizing agent. It is a substance or a compound which undergoes reduction and oxidizes other compound. That we call it as oxidizing agent. And reducing agent are the substance which undergoes reduction and undergoes oxidation and reduces other substance. Okay. Yes. So a substance supplying oxygen, as I said, or electronegative element, basically oxidizing other compound, other element, and removing hydrogen or electropositive element to oxidize the other element. Such substance we call it as oxidizing agent. Yes. Yeah, a substance that can accept electrons. When it accepts electron, that means it accepts the electro, yeah, it basically removes electropositive element and supplies electronegative element. Okay. Yes, the prominent element in the compound shows decrease in oxidation number. That means the element itself, the compound itself, which acts as oxidizing agent, undergoes reduction, to be in simple words. So chromate ion reacting with SO3 2 minus will give Cr3 plus and SO4 2 minus. In this case, if you observe, Cr2O7 2 minus is supplying oxygen to sulfur trioxide ion to find out to form sulfate ion. Clear? So one oxygen is getting added. Meanwhile, chromium is getting reduced. Okay, it is getting reduced to Cr3 plus. Yes, here are few examples of oxidant or oxidizing agent. K2Cr2O7, KMnO4, HClO4, H2SO4, KClO3. Wherever they have a tendency to give oxygen or remove hydrogen, they will act as oxidizing agent or they will undergo reduction. Yeah. Reducing agent, a substance removing oxygen, the opposite of oxidizing agent, removing oxygen or electronegative element, adding hydrogen or electropositive element. Yes, so those are reducing agent, and these reducing agents or compounds will undergo oxidation. Okay? Their oxidation number will increase because they will undergo oxidation. Okay? For example, if I take zinc and treat it with phenol, benzene will be formed, and this oxygen will be taken away by this zinc. Okay? This hydrogen further attaches to this carbon, whereas this oxygen will form bond with zinc. That means what? Oxygen, zinc is taking away oxygen, or it is undergoing oxidation, and it is acting as very good reducing agent. Yeah. So metals usually act as very good reducing agent. sodium, aluminium, zinc. Yeah, because they are very eager to undergo oxidation. Sodium is very eager to be in Na plus. Aluminium is very eager to be in Al3 plus. Zn, Zn2 plus. So because of their eagerness to undergo oxidation, they act as very good reducing agent. Yeah. And non-metals want to take away electron. Yeah, we heard that, right? Non-metals want to take away electron. Since they want to take away electron, they want to undergo reduction. So they are acting as very powerful oxidizing agent so that they can undergo reduction. Got it? Yes. Metallic hydrides like NaH, LiH, KH, CaH2, etc. Yes. So they will uh, remove hydrogen from the other atom. Fine. The compounds having an element in its lowest oxidation state, such as, yes, whenever they are in lowest oxidation state, they have chances of undergoing acting as a reducing agent because they want to increase their oxidation number. Okay. Yes. SO2, HNO2, H2O2 can also act as oxidant as well as reductant. Why so? Because if you look at oxygen, for example, here the oxidation state is -1 because it is peroxide. So now this -1 can either go to -2 or it can go to 0. Isn't it? If you take O2, it will be 0. If you take H2O, it will be -2. That's why sometimes it can act as oxidant, sometimes it can act as reductant. Yeah. Similarly, SO2 also, here it is +4. It can be in +6 or it can be in plus or 0. Yeah. HNO2 also. Yeah. It can be in +3, +5 or 0. +3 is HNO2, +5 is HNO3, 0 is N2. While sulfur dioxide, here is a question. While sulfur dioxide and hydrogen peroxide can act as oxidizing as well as reducing agent in the reaction, nitric acid acts only as oxidant. Why? Yeah, why nitric acid act only as oxidant? That means nitric acid has only one option to get reduced and not to get oxidized further. Yeah. Why do you think it is like that? Yes. Yes. Because the maximum possible oxidation number for nitrogen is +5. So further increase in oxidation numbers of nitric acid is not possible. So it cannot undergo oxidation. So it cannot act as reducing agent. Hence it only acts as oxidizing agent. Okay. So sulfur oxidation state is +4. Peroxide oxidation state is -1. So -1 has a possibility of -2 and 0. SO2 has a possibility that sulfur +4 has a possibility of +6 or 0. So that is why it can undergo either oxidation or reduction. Okay. In nitric acid, nitrogen is already in highest oxidation state +5. So it cannot increase any further. Hence it will only undergo reduction. Yes. Now the next discussion that is going to be uh, dependent upon redox reaction. Yeah, combination reaction, decomposition reaction, displacement reaction, all of those things we will learn in combination to redox reaction. Okay. Once this oxidation number is very clear, then it is very easy to understand all types of reaction and further balancing of redox reaction as well. Okay. So if you have understood this nicely, then this chapter is in your hand because you can score very well. Yeah. Yeah. Combination reaction. What are combination reaction? In which two atoms or molecule combine together to form a third. It's a combination reaction. So Mg and O2 combines to form magnesium oxide. But in this case, what is happening? Magnesium, which has oxidation number of 0, is now becoming +2. So oxidation or reduction? Increases. Oxidation number increases means it is oxidation, and oxidation number decreases means it is reduction. Okay, so oxygen undergoes reduction, magnesium undergoes oxidation. So this is one example, one type of redox reaction. The next type is decomposition reaction. The reaction in which molecules break down to form two or more components. The decomposition reaction, for example, if I take KClO3, it can decompose as KCl and O2. Oxidation number of O2 will be 0 and oxidation number of Cl will be -1. Whereas over here, in case of KClO3, oxidation number of potassium is +1, oxidation number of oxygen is -2, and chlorine is +5. Okay, so +5 is becoming -1 and -2 is becoming 0. So -2 to 0, that means -2 to 0, that means it is undergoing oxidation, and +5 to -1 means it is undergoing reduction. Yeah. Other type is displacement reaction. What is displacement reaction? Reaction in which one atom of a compound is replaced with other or ion. Both are possible. Now, metal displacement reaction, when a metal is displaced by some other metal, then it is metal displacement reaction. For example, CuSO4, when it reacts with zinc, zinc sulfate will be formed and copper solid will be deposited. So here if you see, copper has oxidation number of +2 and zinc has oxidation number of 0. But then 0 changes to +2 over here and copper +2 changes to 0. So if you see, this is undergoing reduction because oxidation number is decreasing, and this is undergoing oxidation because oxidation number is increasing. Non-metal displacement reaction, in this case, non-metals are displaced. Here is the example of chlorine replacing bromine. Okay, so chlorine gets added to sodium and bromine comes out in free state. Okay, so here the oxidation number of bromine is -1. Here chlorine is 0, the reactant side, and the product side, chlorine is -1, bromine is 0. So chlorine is undergoing reduction, bromine is undergoing oxidation. The next type is intermolecular redox reaction. Intermolecular redox reaction are special type in which what happens in a compound, two atoms, sorry, that is intramolecular. In intermolecular, two different compounds, same element, will undergo oxidation and reduction. For example, if you take SnCl2, FeCl3, here you can see that stannous +2 will become stannous +2. And ferric +3 is becoming +2. So ferric chloride becomes ferrous chloride, stannous chloride becomes stannous chloride. So atoms oxidation number just changes. That are intermolecular redox reaction. Yes. Intramolecular redox reaction, when in the same compound two elements are present and these two elements undergo oxidation and reduction. Right? For example, KClO3, in this case +5, the Cl is getting reduced and -2 is getting oxidized. Yeah. Yes. Next is disproportionation reaction. Reaction in which reduction and oxidation of same element of a compound. So what does that mean? Here Cl2, if you observe, it is in free state where its oxidation number is 0. But in disproportionation reaction, it disproportionately undergoes oxidation as well as reduction. Clear? So these are also called as auto-redox reaction. They themselves will undergo oxidation also, and they themselves will undergo reduction also. Okay, so these are disproportionation reaction. Yeah, disproportionation reaction cannot be shown by an element in a compound if it is present in the highest possible oxidation state or least. Yeah, because let's say if I take HNO, in this case, nitrogen does not have option to undergo oxidation further because it is already in +5 state. So do you think it can become +7? No. The maximum possible oxidation state of nitrogen is +5. Okay. Yes. Whereas in case of HNO2, there are chances. Yes. Because here it is +3. It can either undergo oxidation to +5 or it can undergo reduction to give free state N2. Yeah. So it is not possible when it is having highest possible oxidation state or least. Direct redox reaction, indirect redox reaction is um, something very important to understand, because indirect redox reaction is what um, present in large aspect, like the most important thing to be known for electrochemistry. Because indirect redox reaction is responsible for generation of electric current. Because direct redox reaction, it is a chemical reaction in which oxidation as well as reduction is carried out simultaneously in the same container. Indirect redox reaction, in which oxidation and reduction are carried out separately in two separate half cells, and then they are connected through electrical means. Yeah. The energy is generally liberated as electrical energy. Yes. So try to answer this question. If you have heard the types of redox reaction very carefully, then you will be able to answer this. Which of the following species do not show disproportionation reaction and why? Given example is ClO minus, Cl2O minus, ClO3 minus, and ClO4 minus. Yes. Which of the following species do not show disproportionation reaction? The first case, chlorine has oxidation number of +1. Second case, +3. In third case, +5. In fourth case, +7. So, below this, anything is possible for chlorine? Yes. 0 is also possible. -1 is also possible. Above this, anything is possible for chlorine? No. Because outermost shell of chlorine has only 7 electrons. And more than that, it cannot give. Correct? So that's why disproportionation reaction is not possible when it has highest maximum oxidation state. Yeah. So answer is ClO4 minus. Okay. Yes. So this is about types of redox reaction. In next class, we will be learning in more detail about how to approach balancing the redox reaction. Fine. Hope you understood this whole thing. Yeah? Mainly oxidation number, what exactly it means, and how I can find out whether some element is getting oxidized or reduced using oxidation number. Thank you.